Welcome to MRS Bulletin's Materials News podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Laura Lay. Modern life relies heavily on the natural world. Plants provide us with food as well as raw materials for clothing and support a wealth of other vital natural processes. Although technology can monitor plant health to supply data which humans can act on, one team of researchers is looking at a way to give plants the ability to act on these data and draw chemicals from a reservoir with minimal human intervention and greater precision. In a proof-of-concept experiment, the team has developed a device that can make use of wind-driven plant leaf motion to generate electricity, which can power the chemical delivery system.
With relatively few electrical components, we can use the static electricity forming on the leaves to drive a delivery system. So here we don't need a battery. We don't need any control circuits, microcontrollers. It is basically only passive elements. So this is something which can be completely driven by nature.
That was Assistant Professor Fabian Merda from the Italian Institute of Technology in Genova and the St. Anna School of Advanced Studies in Pisa, Italy. Creation of the device, a Triboelectric nanogenerator, involved an artificial leaf made of a 500 micrometer silicon elastomer layer and an electrode made from indium tin oxide. This was attached to the leaf of the plant. A gold-coated pin electrode inserted into the stem of the plant harvested charges from the plant tissue. As the leaves flutter in the wind, the artificial leaf makes contact with the leaf of the plant, producing charges on both surfaces. When the leaves separate, this causes the electrostatic induction of the charges of opposite polarity in the artificial leaf electrode and the plant tissue. This alternating current was converted to direct current using an off-the-shelf component. Now, the thin layer of silicon directly charges a purpose-built organic electronic ion pump.
It's enough to use a thin layer of silicone to produce electrical charges with leaves. And that we are already studying now since several years. But the combination with this ion pump is something not as straightforward. You may think one thing produces electricity and the other uses electricity to be powered. But such devices have never been powered by this type of energy sources. The type of current or energy harvest with the plant surface produces are very small current spikes with a high voltage.
The triboelectric effect utilized in the leaf motion device relies heavily on some interesting properties of a natural wax that is present on the surface of the plant's leaves.
The waxes are nanostructured. It's a dielectric polymer, so it doesn't conduct electricity. And it's working quite well for producing the static charges. So the triboelectric effect that we use depends strongly on the materials that are in contact. That's why, for example, silicone elastomers together with leaves produce a high charging.
The device is a product of collaboration between the research group in Italy, who are pioneering the artificial leaf, and another group at Linköping University in Sweden, who specialize in the development of the ion pump. To develop this proof of concept, researchers from Italy travelled to Sweden to marry the artificial leaves with the ion pump and test the ability of the device to transport protons.
The ion pump that has been developed by Linköping University is a very specialized device. In this study, we used an ion-selective membrane for H+, so hydrogen. And this can be adapted for the use of plant hormones, which can then stimulate plant growth, for example, or make plants more resilient. A very big challenge was for the PhD student to go to the laboratory, bring the technology there, and being 2,000 kilometers far from our laboratory where we are used to work, where we have every material available in case something goes wrong, and to establish this in another environment. Research and science is often connected to a certain factor of luck. And we were lucky that it worked out. And the experiments immediately showed that each current spike could drive this ion pump.
To be sure that leaf motion, which was initiated using a laboratory fan, caused current harvesting, several control experiments were conducted to rule out leakage through the membrane in the ion pump or electrostatic noise in the environment, which has previously been shown to affect plants. This proof of concept opens up other avenues for research to understand what other technologies could be combined. The device could be used to deliver vital hormones and nutrients, which could make plants more resilient to the effects of climate change, such as drought, and ultimately it provides more autonomy and responsiveness compared to current agricultural methods. This work shows that technology can work with nature to provide benefits for humankind.
There's a lot of opportunities for technology when we not try to dominate nature, which a lot of technology tries to do, but we try to leverage nature in a way that it can be useful for us and also protect the environment.
This work was published in a recent issue of Bioinspiration and Biomimetics. My name is Laura Lay from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org. Follow us on Twitter at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.